been a while since I've done any of these restorations. One of the reasons is I've been redoing a number of things, including rebuilding my test bench here, and you'll probably recognize if you've seen some of my previous videos that there's a lot of new equipment there. But I'm going to get back to the B&K tube testers. And previously I did a B&K 650, a 500, a 707, and a Hickok 600. But this is a B&K 700. Originally, I wasn't going to restore this one because I bought it more to have some backup parts, like a meter and a transformer and so on, for my 707 restoration. But that went so well, and I didn't really need any of the major parts out of this unit. So I decided to see if I can restore this one. First thing I'm going to be doing is mostly just kind of cleaning it up and doing a general visual inspection, and then I'll ohm out the major components, the power transformer and the switches and the pots and controls and so on. Clean them up a little bit, and then we'll get back and I'll show you a little more about where I'm going to go on this B&K 700. I cleaned the top side of the 700, but I thought before I start working on the bottom side that I'd make a few notes on some things. You've probably seen some of this before if you've seen my earlier tube tester videos. The first thing is you really should look around as much as you can, try to get as much data as possible. There's a lot on the web. This is a first page of a many long pages of great information that's on a site called TubeSound. He appears to have an awfully big collection of tube testers and seems to know an awful lot about them, so I suggest that. Another is this book, Tube Testers and Classic Electronic Test Gear by Alan Douglas. Great source of information. The third source is the BAMA website. Boat Anchors Manual Archive is what BAMA stands for. And you can get things like this Model 700 manual at that site. You really should try to download all of that. The last thing that I will mention is I'm about to start cleaning switches and things, and I thought I would mention something that I have found useful, and maybe you will too. This is some electronic cleaner that you can find at places like Walmart and so on. Auto supply stores carry it and so on. It's great stuff, works real well, it's pretty safe. But it does have a problem. You really should read the label, and you'll notice it says that it will remove the lubrication from surfaces. So, one thing that you should be aware of is there are products like Deoxit, a little more expensive, but it not only removes dirt and grime from the contacts, but it leaves a protective surface. And so what I would suggest is you can use this, it's cheaper and it works fine for cleaning, but then you might want to spray your contacts with a light coating of Deoxit when you're done, just to leave a little protection on the metal. You might also want to use a little WD-40 on the mechanical joints, like the bushings and bearings of switches and things like that, because once again, this electronic cleaner will remove the oil from them and leave them unlubricated. So enough preaching. I'm about ready to move on to actually getting some work done, and I'm going to start cleaning the switches and things in this B&K 700. Well, I'm partway through the cleaning. What I've done is I've cleaned the push-button switches. They're here. And to do that, I had to unmount the switch. There's some screws on the other side. And because this capacitor was getting in my way, I replaced it. This is the one that was in there. I generally replace all the electrolytics when I'm doing a restoration. The I thought while I was at it, I would mention something about this switch, that there are some screws that you see right there that hold this, that go through the front panel and hold this push-button switch assembly in place. One thing that I have learned over the years working on these B&K tube testers is you don't tighten those screws down very much. Just snug enough to hold the switch. If you tighten them too much, what happens is this assembly will start to twist, and you'll get all kinds of weird indications. It'll show shorts even though you don't even have a tube in the socket. It'll mess up some of the readings. Sometimes the tests won't work. So when you put these screws back in, just put them in enough to hold this, and then give them maybe a quarter of a turn or so. Don't crank them all the way down. Okay, the next thing I'm going to do is I'm going to power this up and see. By the way, you may notice that the 83 tube, which is used in the circuit, is out, and the 6BN8, which goes here, is also out. I have ohmed out the power transformer just to make sure that the primary and secondary are not open. And the next thing I'm going to do is check these bulbs right here. Now let me show you on the schematic what we're actually going to be doing. These bulbs are a rather clever part of the B&K circuit. I won't go into why they're here, but basically you see that you have AC voltage here that comes down through a pot and then flows through these two bulbs and eventually goes to the other side of the AC line. And the 6BN8's filament is also off this same winding. Those are part of the compensation circuit. And like I say, if you haven't seen my B&K 650 restoration, you might want to look at that one. I talk a little more about what those are used for, but basically they're used to adjust the tube tester for variations in line voltage. And while I'm at it, you may notice that there are some red marks on here. I like to do that to kind of show me where some key voltages are. And the capacitor that I replaced is this 20 microfarad 250. I used a 450 as a replacement. But we'll be testing that in a minute once we install this tube. But first we want to see if these bulbs will light up and if the secondary of this transformer is putting out AC. So let's do that in the next segment. Okay, I've plugged the unit into that Syncor PR57. I'm going to turn off some lights here so we can see the bulbs better. And I've got it set right now for the output voltage. So what we're going to do is we're going to raise the output voltage here to about 110 or 115 volts. And then we'll look down here to see if the bulbs are lit, and they are. Let me show you that. I'll turn these down and up. Once again, we'll check our line voltage here. It's set to about 115 volts, and you see the bulbs are on with some brightness, but not a lot. You can see them better this way. Okay, so the next thing we're going to do is we're going to install the 6BN8 in that socket right there, and see if we can get the plus and minus voltages for the tube tester to work. Okay, now we're going to raise the voltage, and this time I've got the Syncor set to the 1.5 amp range on the meter. See how much current this draws. And of course, if it draws very much at any point, I'm going to turn it down immediately. Now that should be about 115 volts. Check that. Looks right. And looks like very little current. Just a little bit being drawn. And it turns out the filaments, I'll turn this off, you can probably see it better. The filaments are starting to glow on the 6BN8 in there. And the light bulbs are on here. Barely. You can see those. I think I'm going to raise the voltage just a little bit higher to about 120 volts. And the bulbs are a little brighter now. 6BN8 is working. Now let's check the voltage on that capacitor that we put in. That should be about 150 volts or so. I think on the schematic it actually shows 149 volts. And you see that comes off of the C4 there, the 20 mic 250. So let's hook up a meter and check that. Okay, we've hooked up a meter across that capacitor, and you see we're reading 123.6 volts. That's a little bit low. So we may have to check a few things and see why we're not getting the full voltage there. The first thing we'll do is we'll look at this and we'll see what the AC voltage should be coming into the 6BN8, and I think it should be 115 volts. Yeah, right there, and comes over, and you see ties to goes through a resistor and a pot. The resistor goes to the plate of one section, and the pot goes to the cathode of the other section of the 6BN8, and those should produce positive and negative voltages. The positive voltage right there is what's used for the plate of the tube you're testing, and the negative voltage is used for the bias value, and then it's tapped down through some resistors and so on that we can talk about a little later. So let's see if we can find out why it's not putting out 148 or 49 volts. Well, I discovered what my problem was. If you remember, I didn't have the right voltage on this capacitor over here. And the reason was that I wasn't using my new Syncor PR57 correctly. I was reading the wrong scale. I was reading this scale down here. And I thought that that was about 115, 120 volts. But that scale is the amperage scale. I should have been reading this top scale. So when I was setting the meter here, or the variac, or the isolation transformer, I was really only putting in about 90 volts. When I raised it to about 110, this is where you see it is now. It's between 110 and 117. Well, now, on the negative voltage, I get negative 142 or 143. And then we'll move it over here. And you see now I'm getting that 149 volts that I should. So, what we actually had was a case of concentrated stupidity. I should have realized that I should have paid attention to the meter. It's real simple. It actually indicates which scale to read by these little red LEDs or lights that light up. So I was supposed to read this top scale. So anyway, I'm on track now, and that's one of the problems. You know, I used to use that Tenma, and I switched to the Syncor because I found a good deal on eBay, and also because this not only has a little higher amperage output, it'll put out up to 4 amps of AC. The Tenma would only do 3, But it also has this neat leakage feature where you can check for AC leakage, which I may talk about at some future time. But at any rate, you know, when you get a new piece of equipment, you should learn to use it before you start trying to use it on something else. So anyway, on to the next segment, and we'll start checking out some parts of this B&K 700. I've replaced a few more components. I had replaced that capacitor. I now have replaced this capacitor down here, which both of these were originally 20 microfarad, 250 volt, and I replaced them with 20 microfarad, 22 microfarad, 450 volt. The next thing I did was I replaced the 83 tube, or I didn't have an 83 tube in this one. I had taken it out just so I wouldn't break it. So, but what I've done is I've replaced it with a solid state equivalent. And that's that unit you see right there. Down in there you see a couple of resistors and a couple of diodes. You may not be able to see the diodes very well. But basically what that is this circuit. It's a 4-pin socket, and this is an equivalent of a Type 83 tube. If you want to know a little more about this, you can look for it online. There's a bunch of articles about replacing the 83 with silicon diodes, or 83 tube solid state replacement, things like that. Anyway, you can look for that. There's a good article on Tube Sound about it, and in this book, this is the book on tube testers and classic electronic test gear. So what that does is it replaces the 83 tube, and I actually like it better in these B&K testers. It sometimes doesn't work in the Hickok testers I've heard, although I don't have as much experience with those. But I've always been able to make it work in the B&K circuit. So it cuts down on the power consumption, and it, of course, preserves your 83 tubes for use in circuits that are more critical, as I understand the Hickok is. So anyway, the next thing I want to do is start checking some functions on this and see what else needs to be worked on, and then I'm going to do some more cleanup and things of that sort, and see if we can start testing some tubes. I put the 700 back in its case to run a few tests, and what I have in here is a 6AN8 in that socket. You'll notice that socket says 6AN8 6261. Those refer to the sensitivity settings, that is this, which I'll set in a second. So the first thing I do is I'll set the heater voltage to 6 volts. I'll turn this on, and we'll check to see if the filament is lighting up. Now, unlike the 650, the 700 series doesn't have a filament continuity test in itself. You just have to look, and in this case you can see that the filament is starting to light up there. So the next thing we'll do is check the tube for shorts by pushing this button, and there's a light right here, a neon bulb, an NE51, that should come on if there are shorts. You may notice it blinked, and that's normal. It's supposed to do that, and that's actually a way to test if your bulb is still good, because it should blink and then it should go out and stay out. So this tube doesn't have any detectable shorts. Next thing is grid emission, and that's this button here, and for this you'll have to watch the meter pretty carefully, and I'll say when I'm pushing it, and it should move up just a little bit but stay in that little green region right there to the far left. Okay, now And you see it did move up just a little bit. Maybe you can see it better this way. And now I'll turn it loose now. Okay, so there is a little bit of grid emission, but it's well within the good range. Then I'm going to run test 1. Now for test 1, I have to turn the sensitivity control up to the value that is written alongside the tube there, which as you see is 62. So we'll set this to 62 and then we'll push test 1. And it shows good. Then we should set it to 61, which really doesn't make a lot of difference, and push test 2. Now I know this tube is bad. One section, the second section is bad. So it's not going to show anything, but that's part of the purpose here, is to find out if it shows something, it means this tube tester isn't working. And you see there, when I push it down, it doesn't. Now, to kind of prove that that is exactly what, that this tube is half working and half not working, I'm going to put it over here in the equivalent socket of my 707, which is fully calibrated and tested. Turn that on. Give it a second to warm up. And go through pretty much the same test. That is, first thing we'll do is test for shorts, and the little neon bulb should blink. And then for grid emission, there should be a very slight amount. This doesn't show much at all, but this other one maybe needs some calibration. Then test 1. And we have this set at 62. Test 1. And you see it tests about the same. This one tests a little better, or on this tester it tests a little higher. But that's once again probably because this one is calibrated and the other one isn't yet. And then the big thing is in test 2. And you see it also indicates that one side of this or one section of this tube is bad, which I knew it was. So, that verifies that I have a working 707 over here, or at least it'll test one kind of tube correctly. Now let's try a different tube and see what happens. Okay, this time I have a 6AU6 plugged in. And let's see if we can see a filament. I can't see one, and I know this is a bad 6AU6. So let's go over here and see what we get on shorts. Okay, you may notice the meter pegged. That's because in the shorts test, this particular kind of tester, not only this one but also the 707, use both the meter and the shorts light to test for different kinds of shorts. And what this is telling us is there's a heater to cathode short. That's what occurs here. And that's probably why, well, now it is starting to light up. You notice it is lighting up. So, because it indicates a short, you shouldn't do any more testing because you can ruin a tester if you test a shorted tube. That's the reason why you do the shorts test first. So let's go over to the 707 and do the same thing. And by the way, this is a 7-pin instead of a 9-pin. The first one I tested was a 9-pin. Turn this on. And we are getting some glow on the filament. I think you can see that right there. So let's set it to the numbers. It says for 6AU6 it's 82. So we'll set this 82. Come over here and try shorts, and you see the meter on this one also shows that it's shorted. So you see at the top it says shorts reject right there. Anything in this region, if it's way down here it's okay, but anything above that green region is shorted. Once again, the two testers agree, although this one is better calibrated. So the next thing that I'll want to do is go through a calibration procedure on this 707, or I'm sorry, on this 700, and try to bring it up to specs. And that'll be the next, or actually I'm not going to show you a video on that because that's actually in my 707 video and also in the 650 video, and there's plenty about it in the materials that I told you about online and so on. So next thing I'm going to do is probably show you a kind of final segment on this where I'm testing something on this bottom panel. Next I'm going to test a 6F5. This is a fairly old tube used in radios in the 30s and 40s. And one reason I chose this to test is I know it's good, and it tests on this second panel. And just like the 707, the 700 has a switch to switch between the upper panel, which this neon light will be on when the upper panel is active, and the lower panel. Watch the two neon lights. Switch this one on. Now this panel is active. Now based on the listing for the 6F5, which is right there, you see it reads 63740 72110 1. Now what that means is 6 volts on the heater, 37 is the socket, which is, I guess, covered up by the tube right now, but this is 36 and 38, so 37's in the middle. I had to use a top cap connection, and then 7 to 110 and test 1. So once again, the first thing you do is test it for shorts, and you see it's got a little bit of leakage, but the meter is not out of the green and the shorts neon bulb is not turned on, so you can go forward and do the next. We'll test for grid emission, a little bit of grid emission, or at least that's what it shows. Once again, I haven't calibrated this yet. And then test 1. Test 1 shows that this is good. By the way, the sensitivity is set at 40. I think you see over there. So this shows that this bottom panel works, at least for this socket, and since they're wired all in parallel, it's pretty unlikely that if it works for one, that it won't work for another. But I'll be testing some of that as I go on. And the next thing I would do, but I'm not going to do on the video, is go through the calibration procedure on the 700. And the reason is, as I said, I went through that when I did the 707. So I'll refer you to that. They are identical. It's the same calibration procedure, and it's well documented on the TubeSound website and in the B&K manual, and that you can get off the BAMA website and so on. So I won't bore you with that duplication, but this looks like it's going to be a working tester. Needs a little more care and restoration and a little calibration, but I think it's going to serve me well in the future. And this pretty much completes my collection of B&K tube testers, so you won't be bored with any more of these. What I'd like to do now is move on to So what a project that I've been looking forward to for quite some time, which is restoring a couple of Hallicrafters. One of them is that SX71 there, and the other one is this SX62A right here. So hopefully that'll be in the next video or sometime soon, and maybe I can get those two working and be able to listen to some shortwave and relive the days of my youth. I thought I was finished with this 700, and essentially I am, but I went back and watched the 707 video that I had done before, and while I was doing the 700 I mentioned some things that were in that video. Most of them are, but a couple of them aren't. So it occurred to me that probably for completeness I should tie up those loose ends, and then a couple of other things occurred to me that you might be interested in if you're going to try restoring one of these old tube testers. One thing that might be useful to know is the difference between the 700 and the 707. There's very little. The main difference is that, of course, the 707 came out later, so it tends to do more tubes. For example, this socket on the 700 is the only Compactron socket. Compactrons came out toward the end of the tube life, and they were mostly used in color TVs to save space and power. And so unless you're really working on some, I think late 60s into the early 70s tube televisions, you probably don't need that. But that's one of the major differences. This one has a Compactron socket here and then an add-on socket. This one, the add-on socket, is actually a 9-pin. It's a large format 9-pin. The normal size is one of these, and you notice the difference between that and this one. That was another tube style, and there's yet another style called the duodecal, which is a 10-pin socket. Okay, enough about the tube socket differences. Now that I've calibrated, oh, by the way, a Compactron, if you ever see one on a TV, this is what they look like. This is a 6T10, and they have 12 pins, and the idea was to put multi-functions in one tube. So whereas before you might just have two triodes, here you might have a couple of triodes, a pentode, maybe some diodes, all in one envelope. Just saved a little bit of space. Okay, what I'm going to do now is I'm going to get set up to test a tube on both testers to show you, once they're calibrated, that they really do track one another and they're basically the same tester. What I'm testing is a 6SN7 in the model 700, the filament 6 volts, the sensitivity at 78, which you can just read alongside the tube socket here. I've already tested it for shorts and grid emission, and it's good. Now let's look at what test number 1, this is a dual triode, by the way. So test number 1, you'll notice, reads about 74 on the meter. Test number 2 reads about 80. So now let's move it over to the other model 707 and see what we get there. So here's the same tube in the 707, same settings, and I've checked for shorts and grid emission again. Test 1, you notice, reads about 76 as compared to 74 on the other one. And test 2 reads about 81 or so. So basically the two tube testers give you the same results. And that can be useful, particularly if you have more than one tester in more than one location, so that you can kind of compare tubes across those. Okay, the last thing that I'm going to talk about are a couple of the circuit differences between these two, and they are fairly minor. Here are the schematics for the Model 700 and for the Model 707. And one of the things I wanted to show you that is a circuit difference that is important, and this, by the way, is mentioned in some of the articles on Tube Sound and Tone Lizard and places like that, is this resistor in series with the meter. It seems that B&K use two different kinds of meters with different sensitivities. So this resistor, which is a 56 ohm half watt, is in series with this meter. Now if we go over to the 700, we see that there's no resistor in series. They're just connected, the meter is just connected to the switches. Now, this is a peculiarity. It turns out that actually my 700, this one, has the same circuit as my 707. That is, they both have this 56 ohm resistor in series with the meter, which indicates that that they were using this slightly more sensitive meter movement in both of them. So I think what was going on is they started out with this meter movement. Later, they found one that was a little more sensitive, and they started using it, but in the meantime, I think they used up the old meters, and so the schematic is sort of the way they started out building 700s, even though later in production they were really building them more like 707s. So those are a couple of the circuit, or at least one of the circuit differences in them. There are a few others. For example, this capacitor, you'll notice, is a 200 microfarad in the 707, and in the 700 it says 250 microfarad. That's really unimportant. It's really intended just to provide some damping for the meter so that the voltage across the meter can't change very fast. Okay, well, I hope you've enjoyed this look at the Model 700 and a little bit of the comparison with the Model 707. And I said I was going to get started on an SX62A, but I think actually my next little project is going to be adding a test panel to a B&K 650. But I'll get to the SX62 just after that. Hope you enjoyed it. Look forward to seeing you maybe in another video.